All right, this is section 2.1, and we make a little bit, not even a little bit, a significant change in direction. And we move to a topic known as sets. It's nothing complicated, really. And so let's start looking at what sets are. So I'm going to make a little list of the items that we'll need to understand for sets. And the first thing that we need to know for sets is that we need to know a word description of them. So you're going to be able to do a lot of things with sets. The first being that you're going to be able to write a word description of what's going on in the set. So word description is one of the first things that you'll be able to do or should be able to do. Okay, good. So if you take a look at that thing, write a description of the set. So the sets are always noted with braces. So these sets of braces are going to contain some elements of the set. The elements can be anything. They can be words, letters, symbols. You'll see all sorts of different things over the next 3 sections. But what you can do with them is describe that. And when you do a word description of the set, it needs to describe only what is in the set and nothing more. So for example, in this one it says write a description. Your description, if you were to give that description to someone else, they should be able to build that exact same set with nothing more or less within it. Okay? So let's see here. The set of zodiac signs that begin with C. Are there any other zodiac signs that begin with the letter C? I don't really know.
I don't think so.
I think that's probably pretty close, I'm going to guess. But let's see the next one. The set of zodiac signs for October and November. I really don't know that one, and I'm going to guess it's no. The set of zodiac signs. So I'll just give you an example of something that's way off, right? The set of zodiac signs, I think we all know that's for sure wrong, right? Because if we said the set of zodiac signs, somebody else could say Libra or Virgo or whatever it happens to be. So I'm just going to say it's probably A, right? It is, okay? So in other words, your description needs to be accurate. It needs to be precise and should not prompt somebody to put more or less into the set, okay? Write a description of the set. Second thing you need to know before we actually answer this is what a natural number is. Because for the first time you see this natural numbers, you see rational numbers. I'm not going to describe what rational numbers are because this is one of the very few times that it comes up and it's not necessary throughout the semester. But the word or phrase natural numbers, that is really important. We're going to see it happen all through chapters, or this chapter, and then a few times throughout the semester. So what is a natural number? Well, first you need to know that a natural number is denoted with a double-backed N. So if I say if I put down a double-backed N, you're going to think natural numbers. They're going to put it as a bolded N. You'll see it later. What are natural numbers? Well, natural numbers are the set of numbers starting at 1 and going on to infinity. Okay, so those are natural numbers. So is 0 a natural number? No. Are any of the negatives natural numbers? No. Are fractions, decimals, natural numbers? No. Your natural numbers are the numbers that start at 1 and go on to infinity. Okay? Nothing in between and nothing less than that. Okay? So when they say all the natural numbers greater than 2, they're saying take that set and take all the ones that are greater than 2. Does that describe this? Or all the numbers, natural numbers greater than 3. Take the numbers from that set of natural numbers, take out everything that's greater than 3. Does that describe this? The numbers 3, 4, 5, and 6. Does that describe this? So let's talk through this. So I'll tell you for sure D is not the right answer. Okay, so without talking about rational numbers, D is not the right answer. And we're not going to discuss rational numbers really in this class. Now, let's back up to C, the numbers 3, 4, 5, and 6. Now, that would be true if one thing wasn't in that set. And that one thing that makes this untrue is this. That dot, 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 like that dot, 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 tells you that you're dealing with something that goes on forever, on to infinity. So, this means that it's not just 3, 4, 5, and 6, it's more than that, right? So, this set goes onward, so C is out. Let's go back to B, all natural numbers greater than 3. This would be true if it said greater than or equal to 3. But because it says all natural numbers greater than 3, it implies that your list should actually start at 4. Right? Okay, when they say greater, that means you can't include 3. Now, if they say greater than or equal to, then we're okay. So therefore, A is the correct answer. All natural numbers greater than 2. You don't get 2 because it didn't say greater than or equal to 2, but you can start at 3. And that's why A is the correct answer for this particular problem. Okay, so that was a lot of time spent just talking about a problem, but there's a lot of stuff going on. 1, understanding what natural numbers are and what the set of natural numbers are. 2, understanding the terminology of infinity and the symbol for infinity or going onward, the dot, dot, dot. 3, recognizing greater than versus greater than or equal to, less than versus less than or equal to. So those are all very, very important things for this problem, okay? And in this whole chapter 2. All right, so next thing, it says list the elements of the set where you're listing out all the letters in there. So the way you would do this is really simple. So all you would do is, because they want you to write out the letters that comprise that, what you would do is you put the Z, comma, E, comma, R, comma, O. Typically, see how they say comma? Typically what you would do is you want to alphabetize them and order them numerically if there's numbers. So, but I think it'll accept that as well.
I wasn't doing it that one. I had real and the same thing. You
Okay.
just write it out with commas in between.
Okay. So good, you can do it like that, or good etiquette is to order it alphabetically or numerically ascending. Okay, but it's going to accept that, so we're fine. Anyways, there we go. Next. So hopefully you guys are plugging away on your homework at the same time. Let's take a look at this one. Now that you know what natural numbers are, now that you know how to build a set, now that you kind of understand language, right? I think we can do this problem. The set of odd natural numbers greater than 6. So there's 3 criteria here. Odd, natural, and greater than 6. So first and foremost, your answer has to be odds. That means D is out. Okay? They have to be natural. That's natural, that's natural, that's natural. So we're still good, aren't we? Because all these numbers can be found in the set of natural numbers. Third, greater than 6. B and C gone, right? Because these are numbers that are less than 6. So A is the correct answer there. These are odd, they're natural, and they're all greater than 6. Make sense? Okay, hopefully you guys are ahead of me. Please ask if you have questions if I'm moving a little bit too fast for you. Otherwise, I'm going to assume that you guys are doing just fine. Okay, so for the first time now we see some new kind of language. We recognize the set notation with the braces, but things have changed just a tad. We have this X vertical bar and then this symbol here and so on. Let's go and break this down so that you understand. Okay, so the first thing I want to note that you already know is that this N right here is that natural number symbol. Remember I said a moment ago that you would see a bolded N? That means natural numbers, okay? The second thing is that E-looking thing. So that E-looking thing is shorthand for is an element of. So in other words, what this is saying right here is that your numbers x are an element of the naturals. In other words, all of your numbers need to be what? Natural. Now, you may still not understand anything else that's going on here, but just this alone, you should now understand. That right there tells you, hey, we're looking for natural numbers. That's all that's saying. But it's saying it in a little bit more roundabout, more mathematical way, I guess. All of your numbers should be elements of the naturals. In other words, everything needs to be natural. In addition to that, I think this one we all understand, all of your numbers need to be less than or equal to 8. That's what that's saying. So in other words, this is saying all of your numbers need to be elements of the naturals. All of your numbers need to be natural. They all need to be natural numbers. And at the same time, they all need to be less than or equal to 8. You guys following me? Okay. Now, what's this vertical bar x mean? Let's talk about that. So when they do this and write something in there, what they're saying is this is all kind of shorthand for the set of items that satisfy that criteria. So that's what that's saying, is that give me everything that satisfies the criteria on the other side of that vertical bar. So what this is saying is nothing complicated other than all the elements that you're about to see or should list in this set should satisfy this criteria. Don't overthink it. Bottom line is your answer needs to meet these criteria. This, and this. Natural and less than or equal to 8. That's what you got to do. Make sense? Okay, so what is that? Let's look at A. Natural, yes. Less than or equal to 8, yes. Done. B is not good because it's negative. C is not good because, well, negative not natural. C is not good as 0 is not natural. We know that. D is not good because it's just less than 8, not less than or equal to. All right? Okay? Any questions about that at all? So, to me, this is probably the most tricky little piece in this section that you want to have a good handle on. All right? Okay, so number 6, I'm going to skip because it's just like what we did. So I'm going to skip that. I'm going to move on to number 7. Number 7, I'm going to talk about because it's the first time we see a range. So let's take a look here. So looking at number 7, it says all the things in your answer need to satisfy these criteria. What's the criteria? They got to be natural, and at the same time, they have to be greater than or equal to 20, but less than 90. They need to be between 20 and 90, but you get to have 20, but you cannot have 90. One more time, if you didn't know that already, remember that that little bar under here means that you get to have that endpoint. Since this doesn't have a bar or an equal sign, you don't get to have the 90. So what's the right answer? It's got to be A again in this case. Why? It starts at 20. Get to have 20. These are all naturals. You don't get to have 90. You get to go all the way up to 90, not up to, but not include 90. B is not correct because it doesn't have 20, and it has 90. C is not correct because it goes under 20 and goes over 90. D is the empty set, which we'll discuss at another time. Okay? In a moment later, I'm going to discuss and versus or. So I'm going to discuss that in a bit. But all right. Any questions about what we've done so far? Any questions at all?
Not yet.
Okay, all right. Let's go on, shall we? All right, and so here it is, the empty set. So this is the next topic that you're going to see is the empty set. So topic 5 in this section is known as the empty set. The empty set can be denoted a couple ways. Number 1 is with a set of braces that have nothing in it. That's one way. Another way is with an O and a line through it. And very rarely, well, I'm not even going to say the other one because we'll encounter it. But it's really just 2. Braces with nothing in them, and O with a line through it. Okay? What is the empty set? The empty set is sort of like what it sounds like. It's a set that has nothing in it. Okay? So it is a set that is empty, has nothing in it. Let's talk about this. Determine if the given set is the empty set. Now, let's pause for a moment and let's be very, let's think of braces or sets as a basket. Okay? Yes?
Does false also qualify as empty?
Say that again.
Does an incorrect statement also qualify as an empty statement?
Depends. That's the first time I've had it asked that way. Why don't I do the example and see if it answers your question? Or there's like a couple of them coming up, and see if it answers your question. So think of it like a basket. So a set in and of itself is like a basket, okay? All right, bowl, whatever. So this is your set. It's like a basket or a bowl. You're putting things in it, okay? So before there is ever anything in that bowl, there's what? Nothing, right? So we got a basket, we got a bowl, there's air in it, there's nothing in it, okay? So currently, before we dump anything in, it's empty, all right? Remember from the very beginning when we started the class, I said, or started this section, is I said that you can build your sets from anything. Letters, numbers, symbols, words. So if you're looking at this problem here, 0 is an object. Think of 0 as an object. It's a number. 0 in the general sense of things does not mean empty. In this context, 0 is an element. And because 0 is an element, it's like taking like a 0, and if you want to think of it like a 3-dimensional 0, and plopping it into our basket. So now our basket has a 0 in it. A physical 0. Are you guys following me? Okay? So therefore, that is not empty. But then you ask the question, well, they just doubled up, and they also put the empty set symbol in there. Well, I can keep filling that, I can fill the empty space with emptiness some more, and that's still going to be fine. So it's okay to have that. In fact, real quick here, is that the empty set?
Yeah.
Yes, because it's just reiterating that it's empty. So this is the empty set. It is, yes. This, where we have an empty and our 0 in it, is not. Why? Not because of the empty part, but because the 0 is in there. And 0 in this context doesn't represent like nothing. 0 represents an object, an element. It's something that builds or is put into the set. Okay, so super, super tricky with that. Some, maybe you guys are good with it. Some students are good with it, some are not. Yes?
You said whatever the 0 in the bracket thing, that's an empty set, and that's what my question was. So I answered that is the empty set, and this is the empty set, also called the nutshell, is a set that contains no elements. The empty set is represented by brackets or 0 with a line through it. You answer bracket with 0 and the line with it is the empty set. The correct answer is 0 with the line in it. In the brackets is not the empty set because the set contains one element.
Yeah, exactly.
0.
Yeah. So it's not. So this is not the empty set.
No, but mine just had the O with slash in it.
Yeah,
Hers
so-
is just the old slash door, so it.
So it is empty.
Yes,
So
it is
yours
empty.
is empty. So if you have, like, if they give you the braces with the O with a line through it, that is empty.
Yeah,
That's what I
yeah,
answered.
for homework color, that's wrong.
No, it's not, because that's still an item, and so it's still something.
Are they
even if
considering it, they're considering that an item?
Yeah, it considers it an item because it has to be by itself to be empty. So if that is inside the brackets, it still has something in it.
So if there's nothing inside, it's not.
So was that now your question from the very beginning?
No, I feel like that's just wrong.
I think so too.
Yeah.
I've always taught it that way, but for the sake of, and I'll tell you this, shows up on your quiz, you get it wrong, I'll let you have it either way. Is that fair?
Okay.
Either way.
I meant like, if we see something like 3 equals 2,
In the brackets.
or something, like
Right.
something that's incorrect, something that's
Right,
false.
so if it's incorrect, so for example, when we get to these, right, if it's false, then it's empty.
Okay.
Yes. So that's ultimately what it comes out to. This one, I guess maybe they're thinking of it like a double negative. And so because there's emptiness in the emptiness, they're calling it something. It's, anyways, whatever you choose on this one, yes or no, there's, I think, validity to it. I like that you're ahead of it, that's good. So, with that said, let's go do some other ones. Determine if the set is the empty set. So, again, this language right here, you don't have to overthink it. This is saying everything in your set needs to satisfy this criteria. So, X, or the things in your set, the things that would go in your basket, are a living German chancellor born before 1800. Can you think of a living person in general, let alone a German chancellor, who's currently living, who was born before 1800? You can't think of anybody, so you can't put anything in the basket, you can't put anything in your set, so the set is empty. Does that make sense, guys?
I guess that's what I meant about false.
Yes.
I forgot what I remember.
Yes. No, that's good. So now it answers your question, yes?
Yeah.
Yeah. So if you can't think of anything that will be able to put in your set, then it's empty. You have to be able to populate your set with at least one item or element before you can consider it not empty. Make sense? Okay. All right, good. Glad you guys are asking questions. That's good. This one, planet whose name begins with the letter D. Can you think of a planet?
Okay, I kind of thought this one was a little BSy because I'm like, well, I don't know, maybe.
Yeah, that's right, right?
The answer is maybe.
Yeah, the answer is maybe. Well, especially now that the whole planets thing is changing, now that we're doing research on it.
I was talking about aliens, but
Oh, gotcha. Okay.
Yeah.
Well, let's just assume that we're working with like our elementary knowledge of like what the planets that we have in our solar system, right? And so I can't think of anything, so in this case it would be empty, right? Is it? Right? Nothing? It's bad that I don't know these things. It's kind of, yeah. So let's look at this next one. Determine if the set is the empty set. Now, this is a really important question because it now brings us to the topic of and versus or. So let me put that over here actually, and versus or, because I can't see this side of the board, that other side, in my field of view for my camera, for my online class. So, and, I'll talk about or in a moment, but the word and is key because it says it has to happen at the same time. Okay, we'll talk about or in a moment. So and means that these both things have to be satisfied at the same time. So let's take a look at this. The elements in your answer, in your set, have to be less than 10 and greater than 14 at the same time. Is there anything that's less than 10 and greater than 14 at the same time? No. Like if I pick 8, 8 is less than 10, but is it also greater than 14? No. If I pick 16, it's greater than 14, but it's not less than 10. So therefore, you can't think of a number that satisfies both at the same time. You can't put anything in there, therefore it's an empty set. Now, let's pause for a moment, and if we were to change this to the word or, that means that you could satisfy either criteria. So that means I can have a number that's less than 10 and dump all of those into the set. I can have numbers that are greater than 14, dump all of those in the set. I don't have to have them satisfied at the same time. Are you guys following me? Okay. Really important that you understand that language. We'll see ands and ors a lot through, not even now, but a little bit later in the semester. Okay. So I'm going to skip number 12. Well, you can see 12 is an or, right? So that's going to be not an empty set. But anyways, you get the point. Okay. All right. So, are there any questions before I switch gears just a tad and come back to our symbol of an element of? We okay? All right. So with that said, let's take a look at this element of symbol. So recall back here, topic 3, what we first saw maybe about 10 minutes ago, that this E was shorthand for as an element of. So the way you're going to read this is you're going to read this left to right. And if you see this, whatever they give you over here, if you see it in the set on the right, it's true. If you don't see it, it's not. And you're going to see is an element of, and you're going to also see where they do the E with a line through it, and you can assume that an E with a line through it is shorthand for is not an element of, right? So you need to decide true or false based on how it reads. So let's read this. 1 is an element of the set consisting of 1, 3, 5, and 7. Is that true? Yeah. 1 is indeed an element of that, so it's true. Make sense? Okay. All right. Next. Now, take a look at this one. The claim is that 35 is an element of this set. Is 35 an element of that set? Not based on kind of the way that they're writing it. This looks like all even natural numbers, greater than or equal to 18, less than or equal to 36, which would not include 35, so therefore it would be false. Okay. All right, let's keep going. Now, we see the symbol is not an element of. So if it's true, then this one, you won't be able to find it in here. If it's false, you will be able to find it in here. So now let's read it. 1 is not an element of this set, which consists of 1, 2, 3, 4 to 35. But wait, 1 is an element of that. Therefore, that statement is false. Make sense? Questions about that at all? Okay, good. Next. All right, now, when you look at 16, what happens here is that no longer are you being kind of hand-fed the set. This is a two-part problem. You need to build the set, and then you need to verify it. So what is this describing? It's describing what? Natural numbers that are at the same time odd. So this set is saying all the natural numbers that are at the same time, because and means at the same time, right? Odd. Well, what is that? 1, 3, 5, 7, 9, 11, and so on to infinity. 9 is not an element of that. That's the claim. So now that I've rewritten the problem, whereas before they already gave that to you, right? So I needed to translate that so I could see a little bit better. Now I can interpret it and make a decision. 9 is not an element of that. Well, that's not true. It is. So this is a false statement. Okay? We okay? I'm going to assume that all the faces down and you guys are plugging away at your work. Which is fine with me. That's great. Okay. Anyway, 17 I'm going to skip. I'm going to let you guys do that on your own. Let's look at 18. It's not a hard question, but if you have not ingrained the concept of natural numbers, then you will get this wrong. What is this simple statement saying? Claiming 2 is an element of the natural numbers. Is that true? Yes, 2 is an element of the natural numbers. Because you know that natural numbers are 1, 2, 3, 4 to infinity. 2 is an element of the naturals. Good? Got it? Okay. Okay, next topic, cardinal number. Cardinal number is the number of elements in a set. Number of elements in a set. So in other words, instead of saying what the elements are, we're asking or stating how many there are. So I don't care what these are, natural, odd, even, greater than 7, or greater than or equal to 7, less than or equal to 20. I don't care about any of those characteristics. The only characteristic I care about if I'm discussing cardinal number is the number, the quantity of elements. So all you gotta do is count them. 1, 2, 3, 4, 5, 6. That means the cardinal number for the set A is 6. Very important note here. If they do this, and they don't write anything else, you should know that they're asking for cardinal number. So if they just list A, the set A like this, and then they write this, you know that they're asking for cardinal number. What is this? What is the number of elements in the set A? There's set A. We need to count the number of elements. In other words, we need another cardinal number. So later on, you're going to see this happen. Remember that I wrote this up. You don't have to be, it doesn't have to be stated to you in the words cardinal number for you to be able to see that. If they do a lowercase n and the set, let's just say the set, then you know they're asking for cardinal number, or asking to find cardinal number. Got it? Okay? All right, next. So I'm going to skip 20. You could count all those up. Not going to bother doing that. You could do that. Okay, let's look at this one real quick. So it says find the cardinal number for the set given below. Okay, so you're going to have to first populate the set to then figure out how many elements are in it. So X, or the elements in your set, are going to be continents whose names begin with the letter B. Are there any continents whose names begin with the letter B? No. In other words, this is a what kind of set? Empty set. How many elements are in an empty set? 0, none. So your cardinal number for an empty set would be 0. Now what you don't do is you don't put a line through it. The line through it tells you you're dealing with an empty set. But cardinal number is asking you quantity. Quantity is not described using this. Quantity is described using the actual physical number. So 0 is that. Okay? If you are dealing with an empty set, its cardinal number is 0 because there are no elements in it. Okay? Anyways, I'm going to skip 22. You guys can do that. 23. Oh, 23 is what? You don't even have to think too hard. What is 23? 0. Good job. Why is 23 0? Notice they use the symbol here, the lowercase n, because they're saying your numbers in this set have to be be less than 5 and greater than 10 at the same time. You can't have that happen. Now, if they said or, then you would be able to do something like that. In fact, it'd be infinity. Not that that's going to happen. But anyways. So there it is. Hopefully you guys got 23. All right. Equal versus equivalent. let me show you. I always use this as an opportunity to show you that you have options in your set. This is the last topic we're doing for the day. So over here, I want you to see that there are ways that you can get help, emailing me or looking through here. If you go to help me solve this, there is a nice little feature and it will help you solve your problems. And so if you forget, let's say that you've forgotten the definition of equal versus equivalence, you forgot to write it down, go to question help and take a look here. It says what? Two sets are equal if they contain the same elements. So the last topic we're discussing is equal versus equivalent. So what did they say about that? Equal is they have the same what? They have the same elements. It does not matter what order the elements appear. Okay, so that's fine. Is there an element in the first set that is not in the second? In this problem, yes, right? The 9 is in the second set that's not in A. The 14 is in A, but not in B. Therefore, since that is there, since the sets do not contain exactly the same elements, are they equal? They're not equal. Does that make sense, guys? So, for the sets to be equal, they literally have to match up in elements. Got it? So literally, I got to see a 10 match with a 10, 11 and 11, 12, 12, 13, 13. Because this 9 is an outlier, I don't see 9 here, I don't see 14 here, they're not equal. Now let's go to the next thing. Equivalence is if they have the same number of elements. So it's a little bit easier, sort of in a sense, the same number of elements. Equal is a little bit harder potentially because you have to have the same exact elements. Equivalence has its own set of difficulties because you have to have the same number of elements. So, in other words, are the cardinal numbers the same? And the answer is yes, right? 5 elements here, 5 elements here, they're equivalent. Does that make sense, guys? Okay. So, does A have the same number of elements as set B? Yes. And so therefore, are they equivalent? Yes. And so FYI, if you ever need help, there it is. Now, let's talk about equal. I guess there's one more topic, finite infinite. I forgot, but we'll get through this. What time is it? 41. 41? Okay, so we have a little bit of time, right? Okay, perfect. Okay, are the sets equal? Now that we know our definition, are they equal? 1, 2, 3, 4, 5, 0, 1, 2, 3, 4. No, they're not equal. They don't have the exact same elements, so they're not equal. Are they equivalent? Yes, they are because they have the same number of elements. Their cardinal numbers are both 5. All right, got it? Now, let's pause here because this is kind of like your little bit tricky question. Are the sets equivalent?
No. No.
Yes. They're not equal.
They don't have the same number of elements.
No, they're equivalent. They got the same numbers, but they don't have the same number of elements.
Yeah.
Let's So let's do this, okay? Shall we? Let's do it through this. I like the thought process, okay? So I do this every semester. Let's see if we can get this. Are the sets equivalent? Explain. Well, equivalent is what? Same number of elements, right? So in general, this set has what? Technically, it has 1, 2, 3, 4, 5, 6, 7, 8. Technically, the set has 8 elements in it, right? This set technically has 4 elements in it. Agreed? So the sets are equivalent because set A does not contain the exact same elements as set B. That has nothing to do with equivalence, does it? So that's out. The sets are not equivalent because set A does not contain the exact same elements as set B. That's not it either. The sets are equivalent because the number of elements in A is the number of elements in B. I'm gonna go with your suggestion. And tell me why this is true even though my counting says it's not. Because we don't count duplicates. Exactly. So duplicates do not get counted in your cardinal number. That is the important little piece here. Does that make sense, guys? So really important, you don't count the duplicates. Now, the follow-up question, here's an important piece. The follow-up question, are the sets equal? And they're equal as well. Because you don't count, because they have the same elements, you don't have to worry about the duplicates. Okay. Now, it sounds like you guys have probably already gone through finite and infinite. So, I'm not going to go through the rest of them, but I will throw up the note if you haven't seen it. Finite, there's the last few columns of finite versus infinite. Finite stops. Hold on, guys. I still got to record this video for my online. Infinite goes on forever. So when you're looking at your problems, the last 2 or 3 in this section, they're going to be asking you finite versus infinite. Finite sets end. An example of finite set, these are both finite sets because they stop. Infinite sets, like the set of natural numbers right here, go on forever. That's all I have to say about that. Good job. Quick note, this 2-1 homework and quiz is due Monday as if we had class, but we don't have class. Okay?
Is the quiz available like now?
It's now. Yeah, you
Yeah,
can do
it's
it.
available.